So this is the bonus video for MHF4U1 Unit 10-11. The question is on page 331, question 5. Mike is waving a specular in a circular motion at a constant speed. The tip of the specular is moving in a plane that is perpendicular to the ground. The head of the tip of the specular above the ground as a function of time can be modeled by a sinusoidal function. At t equals 0, the specular is at its highest point above the ground. So after we finish reading the question, we can firstly draw a circle on the paper and print the center of the circle. And this is the radius of the circle. And now we can have a look of the question A. What does the amplitude of the sinusoidal function represent in the situation? As we all know that amplitude is the move the highest and lowest in the function and also the graph. So as this is a circle, so the amplitude of this circle is the radius of the circle in which the tip of the specular is moving, because at t equals 0, the specular is at its highest point. So at t0, it at its highest point, and after some time it will come to the lowest point. So the radius of the circle which the tip of the specular is moving is the amplitude of the function. The second one, what does the period of the sinusoidal function represent in this situation? So if we have a look of the period, we can know that the time that Mike used or take to make one circle is a period, because he played or waving a specular in a circle many times at a constant speed. So he do the motion like this: one circle, two circles, three circles. So the period is the time it takes Mike to make one complete circle with the specular. The third question, what does the equation of the x of the sinusoidal function represent in this situation? So if we think about the x of the function, we can know that, so we can just have a look of the graph. The x is this line. So if this is a circle, the x will be the height above the ground of the center of the circle in which the tip of the specular is moving, because the circle is all follow the center by the radius, like everywhere, like it equals the radius and follows the center of this circle, and the circle will not move above the ground. So the x of the function will be the height above the ground of the center of the circle in which the tip of specular is moving. So for the last question, if no horizontal translation are required to model this situation, should the sine or cosine function be used? Because there's no horizontal translations, so for this sentence, at t equals 0, The specular is at its highest point above the ground. So that means t equals 0. Y is at its highest point. So as we all know, if we look at the graph, we can know that when t is equals to 0, y is at its highest point. But if it's y equals sine x, it will be like, it will start here, which is t equals 0, y equals 0. So it's not y equals sine x. This is t equals 0, y highest point. So y equals cosine x will be the answer. That's the end of the explanation of question 5. Thank you.